Okay, so we're going to try this vertex form a slightly different way. So we're going to use this particular equation, f of x equals 2x squared plus 12x plus 10. And we need to remind ourselves of the vertex form. So this is our vertex form here. F of x equals a times x minus h squared plus k. So we need our x terms in a perfect square form. The a is the multiplier, and k is our offset for our output. Our vertex, of course, would be h comma k. All right, so we need to take this equation over here and replace it, or change it, not replace it, but change it so it looks like this. So the first thing that we should notice is that we have an a. Our a is 2, so we're going to take that right out. So remember, when we take out the 2, we also have to factor it out of everything in that equation for these first two terms, because we're dealing just with the x terms in this case. So we want to take the 2 out of the 2x squared, but we also have to divide it out of the 12x. And that's what I've done here in pink. So at this point, we know our a is 2, but we need to get this so that it's a perfect square, because we're trying to make it look like that. So remember, we need to somehow change this to get it to be a perfect square, and we did that perfect square process. So remember that to find a square, we would take half of 6, which is 3. So half of 6 is 3, so we take the b term and we divide it by 2, and then we square it to get 9. So we need a 9 in here in order to create a perfect square. So we've added that 9, and by adding that 9, we've changed the equation a little bit. And so we can never change the equation. So here's our equation up here. We rearranged it a little bit to get to this point, but we never changed the value of it. We just rearranged it by dividing that 2 out, but everything was still the same here. We had our 10. We basically had our 2x squared plus 12x, because remember, we can distribute that 2 into both of these terms. But down here, we've actually changed it by adding 9. So the only way to fix that problem would be to subtract 9 off of this side. But you have to remember that we have this 2 out here. This is the part that's very confusing, is that this 2 is still the multiplier of everything in this parenthesis. So we didn't just add 9 to this. We actually added 18, because we're going to redistribute that 2 back in here, and that's going to give us a plus 18. And when we have that plus 18, that's really what we've contributed. So in order to make it the same equation, we have to subtract 18 over here. So now that we subtracted the 18 over there, we can simplify the plus 10 and the minus 18 and simply just make it a negative 8. So I'm going to rewrite this in a slightly different form. Okay, so I took 2 steps here. I simplified this to just be a negative 8, and then I took this here, which is our whole goal, was to find that perfect square, completing the squares. We tried to find that square, which is just x plus 3 squared. And so the part I think that everybody is confusing is that this actually is the exact same thing as this equation up here. They are equal equations. So I'm going to show you through the math how this actually is the same as that, so that you can see that all of this work that we've done so far to get us to this point really hasn't changed anything. All right, so I'm going to rearrange this. I'm going to change this equation because it was the one that we ended with. and I'm going to prove that it's the one that we started with. So PEMDAS always says we do exponents first. So the first thing we have to do is the x plus 3 times x plus 3. So remember, we use FOIL to do that. So our firsts end up giving us an x squared. Our inside, outside, or outside, inside, x times 3 and 3 times x. That gives us a plus 3x and a plus 3x. And then our lasts, right here, give us a plus 9, minus 8 over there. So we're just keeping that minus 8. Now remember, this 2 is out in front of all of this. The 2 belongs to this entire factor. Okay, all we did here is to expand it through the exponent. Okay, so now we're going to take this 2 and distribute it as we would anything else. Now this could have been combined to be a 6x. And I'm just going to distribute that 2. So now we have a 2x squared. This is the 6x, so I'm going to multiply 6x by 2, and we get a 12x. And then 9 times 2 is 18. And then again, we have that minus 8 out there. Okay, so now we can combine like terms. Here's our only like terms. We have 2x squared plus 12x plus 10. And that's identical to what we started with. So the most obvious question at this point is, why did we go through all of this work just to get it into this form when it was just as easy to leave it in the other form because they're the exact same thing? Well, the beauty of this form is that we know that a equals 2. We can clearly pick that out. We can pick out the fact that h equals -3 and k equals -8. And h and k are the vertex, and 2 is the multiplier. So it tells us that we have a vertical stretch. A gives us the fact that we have a vertical stretch and not a vertical compression. H and K tells us where the vertex is. So now we can easily graph this thing because we know these basic pieces of information. And here's the graph of that equation. You'll notice that the vertex is at -3, -8. Right there. And you'll also notice that it's stretched tighter, so it's going tighter up because when from this vertex, if you were to go over 1 from the vertex, you go up 2. If you go over 2 from the vertex, you go up 8, which is twice as much as what you would have done if you didn't have the multiplier of 2. Because if you take 1 squared, you get 1. If you take 2 squared, you get 4. Well, here we went 1 over, square it, you get 1, but here we got 2. 2 over, square it, you get 4, but here we got 8. And that's what that vertical stretch multiplier does to us. It stretches it, or it actually makes it thinner. It has a vertical stretch to it, so it's stretching it longer. And it's because as we go over from this vertex, the vertex is a very important piece on a quadratic equation because now, regardless of where the vertex is, it's always going to follow the square process, the squaring process. So when we move over 1, we square 1, we get 1. And then we deal with our multiplier at that time. So again, when we went 1 space over, and that would be 1 up, except we have a multiplier of 2, so we went 2 up, and there's that point. We go another space over, so we're 2 over, square 2, and we have 4, but because we have a multiplier of 2, we actually go 8. And it doesn't matter which direction we go, it's the same thing. So we can go over 1 this way, and 1 squared is 1, but because we have a multiplier of 2, we have a point there. When we go 2 over, square that, it would naturally be 4, but because we have a multiplier of 2, we get 8 for our particular graph. And you can continue doing that and graph it very rapidly because we're in vertex form.